Welcome to this video on solving trig equations. This is a concept video which will cover what it is and why we care about it, and I'll do a following examples video afterwards. This video is part of a series covering all things Nat 5 trig. Let's get started. So, although it may not seem like it, we've actually solved trig equations before in Nat 4 when we worked with SOHCAHTOA to find angles and sides in right angle triangles. If you need a recap of SOHCAHTOA and Nat 4 trig in general, have a look at the intro to trig video that introduced this series. Now let's take this right angle triangle and note that we're looking for the angle, and that we've got the opposite, which is the blue one, and the hypotenuse, which is the yellow two. And so we're going to tick off the O's for opposite and the H's for hypotenuse, and we can clearly see that we need to use sine. Sine is equal to the opposite of the hypotenuse, which in this case is just 1 over 2, which is a half. And this here is a trig equation. Sine equals half is a trig equation, and we can get the answer, and we've done this lots last year, by just taking the inverse sine of the half. And if you pop that in your calculator, you'll get that x is 30 degrees. And we can do this for cos and tan too. So if you look at this triangle here, we can see we've got the adjacent and the hypotenuse, so we need to use cos. So cos is 4 over 8. And to get x, we just do the inverse cos of 4 over 8, which is a half, or 0.5. And if you pop this in your calculator, it'll come out to be 60 degrees. One more triangle now. You can see we've got the opposite and adjacent, so we need to use tan. So tan is 1 over 1, which is just 1. And the inverse tan of 1 comes out to be 45 degrees. Having just learnt about the trig graphs across the previous videos on working with trig graphs, as well as the intro video, we can also double check that we get these answers from the graphs. This here is a graph of sine x, and I got this from Desmos, which has got an online graphing calculator. I've used it across previous videos, and I'll put a link in the description. So let's have a look at where sine x is equal to half, and we know from what we just did that the answer should be x equals 30. So we'll go log from a half, and we can see indeed there's an answer. The line crosses the axis here, and if we go down, we can see that this happens when x equals 30. But hold on a second, if we keep going along, we can see that it crosses the sine graph again, and that there's actually another answer here. And no matter how many times you put inverse sine of a half in our calculator, you're not going to get out the second answer, which we can see should be 150. So how do we get the second answer? Because in class or in an exam, you're not going to have a graph this neat. Your graph might look something like this here. Might be a bit neater, I'm not the best at drawing. But you can see that you're not going to be able to work out what the second answer is just from looking at the graph. You'll get an idea, but you won't get the actual exact value. So how can we get this second answer? And furthermore, if we try and work out where sine x equals negative a half, so we'll go along from negative a half, we can see that again there's two answers. But if we put in our calculator inverse sine of negative a half, what do we get out? We get out that it's equal to minus 30 degrees, which isn't even between 0 and 360. So how's that happened? Well, it's actually went backwards and found where it intersects the graph here. But this answer isn't useful to us. When we're solving these questions, we want answers between 0 to 360. So how do we get sensible answers? Well, we can use the symmetries of the graph to work it out. So you can see for sine that either side 90 degrees, the graph is symmetric. So that means points either side of this dotted line here had the same value. And we can see for both these points that's true. Basically, along the line at 90, there's a mirror symmetry on either side. So if you look at 30, we can see that opposite side of the line of 90 is 150. And we can see the distance from both the start and the end of the stay, they're both 30 degrees away, which means that the first answer is 30 degrees, and we can see the second answer is just, you take away 30 from the 180, and you can see the second answer is indeed 150 degrees. So the two answers we got are 30 and 150. But how do we do this for a general point? Let's say we get a different first angle. Let's say the first angle is up here. Well, we can draw a line across, and we can see that it matches up on the other side still. And so if the first angle, the first answer is a distance x away, we'll just call it. Here it looks like it's about 40, but let's just say in general it's x. Then the other point is also going to be that distance x away, but from 180. So we get after we get a first answer, which is just x, the second answer is just going to be 180 minus that x. And we don't need to redo this analysis every single time we have a question. we can store this information, this symmetries, in what's called a cast diagram. Hopefully you've seen this before. It just captures kind of all the symmetries of the graph and it gives us a way to find the second positive answer. And we'll see later on that it also gives us a way to find the two negative answers that we're expecting. And if you haven't seen this diagram before, or even if you have, just a reminder, the A stands for all, S stands for sine, the T stands for tan, and you guessed it, the C stands for cos. And it just represents where between 0 and 360 the graphs are positive. So let's have a look at this. So if you notice, this is for all three graphs. So the blue one's sine, the pink one's tan, and the orange one's cos. It's a little bit busy at first, but we'll look at it in more detail, so don't worry. And we can see that in the first quadrant, in the first quarter of between 0 and 360, so between 0 and 90, we can see that all three graphs are in that section. So that means all three graphs are positive between 0 and 90. And that's why A, all, is in the quarter, the quadrant, between 0 and 90. So let's look at the next quarter, the next quadrant. And we see that it's only the blue curve that's between 90 and 180. And this means it's just sine that's between 90 and 180. Keeping this pattern, we'll look at the next one, which is between 180 and 270. And you can see it's just the pink tan graph that's there. So that means it's just tan between 180 and 270. And lastly, we've got the cos graph between 270 and 360. So let's mark that down as well. Okay, so how can this diagram help us get our answers to our trig equations? So we know the first equation, the first answer for all the positive ones, is just given by the first answer we get. So for example, sine x equals a half, the first answer is just inverse sine, gives us 30, for example. To get the second one, well, we already know how to do that for sine. So for sine, if the first answer is x, which is this guy here, then the second one is given by 180 minus x. And we looked at the example already where if 30 was the first answer, then the second one would be 150. Let's see if we can figure out from just the graphs what the other two ways to get the second positive answers would be for tan and cos. So we'll look at tan first. And for tan, there's no mirror symmetries we need to look at. We just need to remember that tan has a period of 180 degrees, which just means that after 180, the graph just repeats itself. If you want a brief reminder of this, just check the last video on horizontal transformations. So what this means is that any point that's 180 degrees apart will have the same value, like for these guys drawn here. So if we take a kind of random point, let's just pick this one here, and we'll call it a distance x away. If this is our first answer, then our second answer will also be a distance x away from 180 because it just repeats itself after 180 degrees. So that means that our second answer will just be 180 plus our first answer. Let's record this down and let's have a look at cos now. So here we've got our cos graph, and as you can see from the graph, the symmetry is just about the middle, about 180, and points either side of 180 just reflect each other and get the same value. So that means a general point a distance x away. So if our first answer is this x here, then the next one's also going to be a distance x but away from the end. So that means to get our second angle, we should take that first answer we got away from 360. Okay, cool. That's us figured out how to get the second answer for sine, tan, and cos when we've got the first answer. Don't worry if that felt a little bit fast. You don't have to know how to get all the information from the graphs because all that information is contained within this cast diagram. I just think it's interesting and useful to see where that information came from originally. Now let's use the cast diagram in some examples. Okay, so we're starting off with sine x equals a half. We've already looked at this, we know what the answer should be. But I want to show you the general procedure how to use a cast diagram to do a question. So first of all, you don't have to use the graphs like I said, but it's a good idea to sketch them just to get a general idea of what the answers should be before you do the question, so you know you're right. And it also helps you figure out what two quadrants to use. So we can see the first answer here is just after 0, so it's going to be in the all quadrant because it's between 0 and 90. And the second one's going to be just before 180, so it should be in the sine quadrant. And this is a general feature of these questions, is that the first positive answer will always be in the all section, and the second one will just be in the section that the actual function belongs to, i.e. sine goes to sine, and cos goes to the c section. Okay, let's get started. We know that the first answer will just be the inverse sine of a half, and we've already done that before, we know it's 30 degrees. And to get the second answer, we just take that away from 180. It tells us right in the cast diagram how to do it. And that gives our two answers of 30 and 150. I won't go through the next two examples explicitly, I'll just briefly say how to start them, and we'll go through more examples just like these in the examples video will follow this one. So for cause, we can sketch a diagram and get an idea what the answer should look like. We look for one below just before 90, which is obviously the first quadrant, and one just before 270, which will be in the, or just after 270, sorry, so it should be in the cause quadrant. And again, as you can see, it's just all in the cause. And for tan, exact same situation. We'll quickly sketch the graph out, look at the answers, and again, just in the all quadrant and the tan quadrant. And you get your first answer just by doing the inverse cos or tan of half, and then second one just from doing what it tells you in the cast diagram. Okay, so that's us figured out how to do the positive, get the positive answers. Do we need to go through this whole rigmarole of figuring out the graphs and choose again to get the negative answers? No, we don't. Because, let's look at a few examples, I'll show you why. So for sine, let's have a look at what the negative half answer should be, okay? We notice that one's just after 180, which would actually correspond to the tan quadrant, the T quadrant. Another one's just before 360, so that corresponds to the C quadrant. And obviously, if sine is positive at A and S, that means it's negative in TC, so we can just use the T and C quadrant to get answers. So let's tick off T and C. So we still need to get the first positive answer, so notice how we put positive at half in this and not negative at half. We still have to get a first positive answer, but this isn't one of our solutions. We just use it to get the other two answers. So we take that 30 and we stick it in the T quadrant, first of all, so we just add it on at 180 to get our first answer. And then we have to put it in the C quadrant to get our second answer, and that gives our two answers. And the same process for the other two. For cos, we just tick off the S and the T quadrant. We'll draw the graph first, and then we tick off the T quadrant as well. So again, you just tick off the opposite quadrants as if it was positive, and do the exact same thing. You find the first angle, but that's not a solution, and then you just find the other two using the opposite two quadrants. Tan, we'll sketch the graph out, and we'll tick the other two quadrants, so that we'll tick the opposites to A and T, we'll tick S, and we'll tick C. So we've established how to get both solutions, positive or negative, but is there always two solutions? So for sine and cos, there's nearly always two solutions. Whenever we try to solve for sine or cos x between 1 and minus 1, like these guys here, we just use the methods we used before and there is two solutions. But if we try to solve it when it's exactly equal to 1 or minus 1, then there's only one solution. So for example here, sine of x equals 1, then x equals 90 only. And for cos x equals minus 1, then x equals 180 only. And when we get these values for the graphs, you can read them straight off, or you can pop in your calculator and it'll work fine. And there's zero solutions otherwise, so when it's above 1 or below minus 1, there's no solutions, like these guys here. I've never seen any past paper questions come up where there's not two solutions, but you should know that there's other possibilities. And for tan, there's always two solutions because tan shoots up to infinity in both directions, so all numbers are possible, like a half or minus 5. Let's round out the video by looking at why we care about all this. So, equations involving trig functions appear across all of physics, so we need to know how to solve equations that include these terms. As an example, here's a past paper question. We'll go through it in more detail in the examples video to follow this one. But if I just write out the equation a little bit bigger for you, it says that the height of the blades, blade A, this guy here, is expressed in this equation here, 40 plus cos x, 23 cos x, where x is just the angle from the vertical, i.e. this guy here. And if we ask the question, when is the blade 63 metres off the ground, then if we sub it in our equation, so the height is just 63, then it's asking us when is x, what is x when, what's the angle when we're at 63 metres high. So I'm going to do a bit of rearranging. I'll take the 40 off from both sides, so we end up with just 23 equals 23 cos x. And if I divide by 23 on both sides, and I'll change the order just so the cos on the left, and we end up with cos x equals 1. And we can see this is the form of the simple trig equations that we've already been dealing with. And if you pop that in your calculator, i.e. you put in your calculator the inverse cos of 1, or you just look at the graph, you can just one straight off the graph, you'll find out that it's actually at 1, 0. So you can see from just the picture that obviously x being 0 just means it's at a starting position, and so it means that 60 metres is the highest point in the graph. And another reason you should care about this is that you'll be solving harder versions next year and higher, so it's good to get a grip on it now. This brings us to the end of the video. If you want to see more practice, how it also works in more explicit examples, look at the examples video to follow this one.